So today we're going to look at Algebra 2, Section 1.6, Linear Systems. How can you find and represent solutions of systems of linear equations and inequalities? First, we need to start out with what is a system of linear equations. It's a set of two or more equations using the same variable. The solution of a system of linear equations is the set of all ordered coordinates that simultaneously make all equations in the system true. The system of linear inequalities is a set of two or more inequalities with the same variable. The solution of this type of system is where the solution spaces overlap. So we want to recall from Algebra 1 when we first learned how to graph inequalities that if you have a less than or greater than sign without an equals to sign, then you have a dotted or a dashed line that you graph. If you have a less than or equal to or greater than or equal to, then you'd graph a solid line. And then we have to shade when we graph inequalities. So if it's a y is greater than or equal to, we will shade above our line. Y is less than or equal to, we shade below our line. So we're going to start out with the very first word problem. It tells us that Malcolm earns $20 an hour mowing lawns and $10 an hour walking dogs. His goal is to earn at least $200 a week, but he can only work a maximum of 20 hours per week. Malcolm must spend at least 5 hours per week walking his neighbor's dogs and wants to know how many hours should Malcolm work at each job in order to meet his goals. So step number 1, we want to define our variables. We can just call X the mowing lawns. So we will use X for mowing lawns, and then we will use Y for walking dogs. So now we want to write inequalities to model the constraints. The easiest one is here what says Malcolm must spend at least 5 hours per week walking his neighbor's dog. We said that Y was our dogs, so Y has to be greater than or equal to 5. The next one, it says he can work a maximum of 20 hours per week, so no more than 20 hours. He can do mowing lawns and walking dogs, so that would be X plus Y has to be less than or equal to 20. And then finally, how much he's going to make. So he makes $20 an hour mowing lawns, so that's 20X. I'm going to add to that what he makes walking dogs, which is $10 an hour, so that's 10Y. His goal is to earn at least $200 a week, so all of that added together must be greater than or equal to 200. Step number 3, solve each inequality and then graph. So solve each inequality for Y. So our Y is greater than or equal to 5 is already solved for Y. But X plus Y is less than or equal to 20. All we have to do is subtract X over. So I get Y is less than or equal to negative X plus 20. And then I can take the 20X plus 10Y greater than or equal to 200. Move our 20X over, so then we get 10Y greater than or equal to negative 20X plus 200. And when we divide by 10, we get Y is greater than or equal to negative 2X plus 20. These are the three that we'll graph. X is mowing lawns, so this is mowing. Y is walking dogs, so this is walking up this way. I know that I have to go up to at least 20, so I'm going to go ahead and do a scale of 2s. So this would be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And do the same thing this way. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. All right, the very first one I'm going to graph, Y is greater than or equal to 5. That's just a horizontal line at Y plus 5. So Y plus 5 is going to be between 4 and 6. This is Y is greater than or equal to, so it's a solid line. So solid line. And then I want to shade Y is greater than, so I shade everything above that line. I'm going to go ahead and switch colors to do the different graph. All of my lines are going to be solid here because they all have equal to signs. So now if I do Y is less than or equal to negative X plus 20, my Y-intercept is 20, so I start here at 20. My slope is negative 1, so down 1 over 1. But since my scale is in 2s, I can go down to over 2, same concept. do that all the way across. Like my x-axis. Draw that line. Here it's y is less than, so I'm shading everything below the line. And I'll switch colors one more time to do our last graph. Y is greater than or equal to negative 2x plus 20. Again, I start at 20 for my y-intercept. But this time my slope is down 2 over 1. So down 2 over 1 puts me halfway between here. Down 2 over 1. Down 2 over 1 halfway. Puts me there. Halfway. That one. There. So we're about right there. Draw that line. Y is greater than or equal to, so that's everything above that line gets shaded. I'm going to go ahead and switch to black so that we can see. We are interested in where all of our shadings overlap. Okay? I always like to just put a big S in my solution space so I can see that in here is where all of my shadings are overlapping in between these three lines. So what that really means is that I have multiple answers. Any ordered pair inside that overlapping area is an answer. So one possible answer, let's see, over 12, it looks to be up to 7. So 12 comma 7 is a possible answer. However, if I went over 10 and up 8, that is also a possible answer. I could go over 6 and up 13. That would also be a possible answer. So this says he could do 12 hours mowing or 7 hours walking the dogs. Hit his goal. He could do 10 hours mowing, 8 hours walking the dogs, still meet his goal. So lots of different possible scenarios that he could do to meet his goal there. Let's look at the second page. So now instead of a word problem, we just have 4 inequalities that we want to graph. We have 2x plus y is less than or equal to 14, x plus 2y less than or equal to 10, x greater than or equal to 0, y greater than or equal to 0. The ones that don't have y on the side all by itself, we're going to go ahead and solve. So I'll start with the first one, 2x plus y less than or equal to 14. So when I get the y by itself, y less than or equal to negative 2x plus 14. So I'm going to graph this one. Is going to be one that we graph. And then the second one, x plus 2y less than or equal to 10. Get the y by itself, so subtract x, and then divide by 2. So we end up with y less than or equal to negative 1/2 x plus 5. And then these two already have a variable on the side all by itself, so we can go ahead and graph. Again, I'm going to go ahead and change my scale. The bottom, my x's, I can keep in by 1s, but my y's, since I need to go up to 14, again, I'm going to go by 2s. So this would be 2, 4, 6, 8, 10, 12, and 14. The x is greater than or equal to 0. Okay, that's going to be an easy one to solve. X is greater than or equal to 0. That's basically my y-axis. That horizontal line going through my y-axis. X is greater than, so that's everything to the right-hand side gets shaded. If I switch colors, now I'm going to do the y is greater than or equal to 0. So that's all of my y's positive up here. Greater than or equal to 0, everything gets shaded above. I'm not going to shade the left-hand side over here because I know that my shadings have to overlap to be part of the solution. So I know I'm just looking at this part right now. Switch colors again. Now I'm going to go ahead and graph the y is less than or equal to negative 2x plus 14. So my y-intercept is 14, so I start at 14. My slope is negative 2, so down 2 over 1. I'm going to stop when I get to the x-axis, since no, I'm not going to go below the x-axis. My shading that matters. Y is less than. Okay, so again, now I'm just, this little triangle area in here is all that's going to be shaded with the overlappings. And so finally, let's switch colors one last time. Y is less than or equal to negative 1/2 x plus 5. So this time, my y-intercept is 5. My slope is negative 1/2. So I go down 1 over 2, down 1 over 2, down 1 over 2, over 2. And I can go ahead and draw that line. And I see that y is less than. Everything in here, this little area, is all going to be solution space for us. So again, if we wanted to look at possible answers, so points such as, I could have the point 2, 4, the point 4, 1, the point 0, 2, etc., etc. Lots of different possible answers there that would work. Right, our last one that we're going to look at, 2x plus 7y greater than or equal to 1. So I'm going to go ahead and solve this and get the y by itself. So when I move the 2x over and divide by 7, I would have y greater than or equal to negative 2/7 x plus 1/7. I have this in blue, so I'll just go ahead and graph this. I don't think I'm going to have to change my scale any. So here my y-intercept is 1/7. Obviously, I don't know exactly where 1/7 is, but I know it's just a little bit above this of 0. So then I'm going to go up 2 over 7. I could have gone down 2 over 7. This is a solid line, so there's my solid line. Everything above that line is getting shaded because it was y is greater than. So I know everything above. I'm going to switch colors. Go to my second inequality, 3x less than 2. I just need to divide by 3, so I get x is less than 2/3. This is going to be a dotted line, a vertical line, so 2/3 a little bit in between 0 and 1. X is less than, so that's everything to the left-hand side of that. And again, if I'm looking at overlapping, you see it's just going to be that part right there. I don't have to worry about shading. Switch colors again. Let's do x minus 6y. So go ahead and work this one out for you. So I'm going to move my x over, so I have negative 6y greater than or equal to negative x minus 43. This time I need to divide by negative 6. So I get y. Remember the rule from Algebra 1, when you multiply or divide by a negative number, you have to flip your inequality sign. So it becomes y is less than or equal to 1/6 x plus 43 over 6. It's not going to be a nice whole number, but let's see. 6 goes in 43 7 times, so that's about 7 1/6. So my y-intercept about 7 1/6. A little bit past 7. And then my slope is 1/6. So I would go up 1 over 6, or I could have gone down 1 over 6. This again is a solid line. I want to continue going down 1 over 6 or somewhere out this way. So let's see. Go that line. And y is less than, so again, I'm just going to do what I know is going to overlap. So right now, this is what I know is overlapping. And one final color for the last one. Again, I'll come down here and solve that for us. So first I'm going to move my 8x over. So I have 5y greater than 8x plus 13. Divide everything by 5. Y is greater than 8/5 x plus 13/5. So 13/5, that's, let's see, 5 goes into 13 twice. And then we have 3 left over. So 2 3/5. So up 2 3/5. Approximately there is our y-intercept. My slope is up 8 over 5. Somewhere about right there. I could go down 8 over 5. So, like that is the line. And it was supposed to be dotted, so I'm going to go ahead and just take some of that out. And then we'll go back, make it look dotted. There we go. All right, and it was y is greater than, so above. And so again, if I'm only looking where it overlaps, we're like this area in here. So this would be our big solution space. So possible answers that I have